So we now transition to the second way in which relatives are recognized, where it's not innate. It requires imprinting. It requires some sort of learning which leaves a long-lasting message of it. Imprinting. So now we got imprinting in yet another use of the word, and major use of it come next Monday. Imprinting, how an animal learns who its mother is, how a mother learns who its babies are, how it imprints on the smell, on the sound, on the whatever of its offspring or parent, how that learning goes on. What is clear is that's a case where the learning occurs at that point is innate. What is learned is experiential. Important sort of distinction there. Okay, so what goes on with this? So in lots of species, you learn the sound of your infant's voice. In lots of species, you learn the odor. In lots of species, you learn what they look like. Different species, different modalities that dominate. What goes into, for example, learning what your offspring smells like? Remember, it's not innate in these cases. For example, a goat, a sheep, whatever, they do not innately have the means of recognizing, oh, this is somebody whose major histocompatibility proteins are fairly similar to mine. In fact, they share 50% homology. Oh, this must be my child. That's not done that way. These are not innate cases. So what sort of rules might you have for how to recognize your offspring? Here's a simple one. Okay, there's a whole bunch of babies out here, and which ones are mine? And I'm a goat trying to figure out which one I'm going to nurse. What would be a good rule that is not innate? Instead, building on learning something at that point, I know I'm going to start taking care of whichever kid there smells like my vaginal fluids. That's a pretty reliable way of figuring out this is somebody you just gave birth to. Or this is someone who I lick as they're first coming out, and for a while afterward, I figure out who am I nice to? Someone who smells like my saliva. Someone who I scent mark right after this is someone who smells like my whatever glands I'm using there. This is someone who smells like my amniotic fluid. This is someone who, after I get that learned, I then nurse him for the first time. This is someone whose mouth smells like my milk. You could see now in this case, it is learning being built on top of whatever your own recognition system is of smell. You can have elaborations on this. How do you recognize a sibling in species where it is learned in this imprinting way? Oh, I'm going to imprint as a relative on somebody who smells just like mom. Somebody who smells like mom's vaginal fluid or her saliva or any of that same stuff going on there. Or I'm going to be nice to someone who smells like someone I mated with back when. That's another strategy. In various species, you could begin to see how all of these are ways of just getting logical information. Someone who has the voice like someone who I heard peeping when they were still inside the egg. Oh, it's them. I'm going to nurse. No, I'm not going to nurse them. I'm going to give them worms or whatever it is birds do. But all these ways of using sensory information to say, oh, that's the one, that's the one, that's how I know it's them. So all sorts of ways in which this could be done. How can you prove that this is not hardwired, this is not absolutely dominating? A technique we've been hearing about already, which is that cross-fostering business, which is you take newborn whatevers and you switch mothers on them, and the mothers will take care of them. What does that tell you? It means other attributes of these pups coming over to them, these rat pups, override the fact, wait, these kids don't smell like my vaginal fluid. Wow, they're cute though, and there's no other moms around, and they sure look cuddly, and so maybe it takes you 10 seconds to decide this is one of mine instead of 3 seconds. You have different things being played out there, contrasting sort of signals coming through. So that's another domain of doing that. So now we move to us and how we do recognizing relatives. And initially, what the answer seems to be is that we have a different version of it. We do not recognize relatives innately, nor do we recognize relatives by imprinting. We don't do that deal of like we smell our parents right after they're born, or we sniff the vaginal fluid and that's how we know who mom is forever after, or stuff like that. So we don't, instead what do? We do it cognitively. We figure it out. We think about it. We think about it with active, conscious, cognitive rules of how you know a relative is. And of course, what we're going to see shortly is that's not really how it works a lot of the time. But for a first pass, we do it cognitively. So now you do it instead of, this is someone who smells just like my vaginal fluid, the way the goats are doing, or this is someone who I innately recognize as my child, the way the rats are doing it. You're saying, well, that's the baby I just gave birth to, because they haven't taken him out of the room yet, so that must be a cognitive strategy. How do I know who the father is? Not because I can smell in the babies 50% sharing their major histocompatibility gene. This is the only person I had sex with during the cycle that I conceived. A cognitive strategy. This is what humans do again and again because we can think. We can go through stuff like that. We can also do other versions of it, which is, well, this is someone who I saw mom give birth to. Or at least when they took me out of the room and then they like gave me some stuffed animals to keep me from like getting too upset, and they said, here's your new baby, whatever. Oh, okay, which is a variant on, this is someone who's been around ever since I saw mom give birth to that individual. This is someone who looks like me. This is someone who looks like a family member. All of these cognitive strategies going into that. We think about it. We think about it. And it turns out we have brain mechanisms that are good for doing that too. But we're not the only species that thinks about it in that way. For example, baboons, wonderful study a few years ago, baboons can do this with some sort of statistical thinking. Okay, baboons are polygamous. Females will mate with a bunch of different males during her cycle and conceive, and thus it's not at all clear who the father is, but everybody there plays a guessing game, and everybody does some statistics. The usual rule is, baboons being a highly tournament species, males do no parental care of offspring. Turns out that's not quite the case. Some males do, when they're pretty sure who their kid is. And here's how it's done. You are a baboon and you are just hitting puberty, you're female, and what goes on is for like your first half dozen cycles, you're cycling with, you're probably not ovulating yet, you're not quite fertile, this happens in humans as well, and none of the big high-ranking guys are terribly interested in you. Probably because you're not pumping out a whole lot of interesting pheromones yet. So who do you wind up with? You wind up with some poor like adolescent schnook who has no chance to mate with anybody else, and nobody's contesting his ability to have a consortship with you. So you do all of your mating with him. The vast majority of the time they're not fertile because you're not really off. Every now and then, though, you get this like junior high school baboon guy who gets his girlfriend pregnant, and he's the only one, and what tends to happen then is when she gives birth, he gives a fair amount of parental care to the offspring. So what does he have as a rule there? If I'm the only one who mated with her, if they're using a cognitive strategy, then I'll take care of the kid to some extent. And it is a sight to behold at how incredibly inept an adolescent male baboon is when he's trying to be paternal. But what you wind up seeing there is, well, maybe he's imprinted, maybe he's doing major histocompatibility, gene innate stuff, or maybe he's actually thinking, hey, I was with her 24/7, so it's gotta be me, I'll take care of the kid. Now you see the more complicated circumstance where it's a more desirable female, more mature one, where there will be a bunch of males contesting. And what you will tend to see is 2 days before and after she ovulates, she'll be mating with number 10. A day before and after, she's mating with number 3. The day of ovulation, she's mating with number 1. That tends to be the pattern. Stay tuned. It doesn't fit that perfectly because female baboons also have some opinions about who they want to mate with. But nonetheless, there winds up being this pattern just like that. So there winds up being this pattern, and thus you're the male afterward when she gives birth, and you're trying to decide, is this my kid? Or should I give some male parental investment? And what is shown is baboon males do statistics. They do probability. What they do is, if this was a male who was mating during her prime ovulatory day, he is more likely to take care of the kid than a male who is mating during this window or this window. They are playing probability. They're not very good at it, no surprise, but nonetheless this pattern emerges. That's not innate recognition. That's not innate recognition of some smell. That's just thinking through it. Was I with her? Yeah, but she sure smelled a lot better the day after, and that other guy was with her, so I guess I'm in this category. Okay, well, I'll smile at the kid now and then and tell them I like their piano playing, but I'm not gonna like invest anything kind of stuff there. Here you see a conscious cognitive strategy.